Hello everyone, welcome back to my channel. Today we are going to learn how electricity is generated from heat, that is thermal power plants. Let's understand step by step how this huge system works. So, what is a thermal power plant? A thermal power plant is a setup where heat energy is converted into electrical energy. The heat comes from burning fossil fuels like coal, oil, or natural gas, or sometimes from nuclear energy, solar energy, or even biofuels. Among all, coal-fired thermal power plants are the most common. At first, fuel is burned to produce heat. The heat is utilized to convert water into steam. The steam then rotates the turbine, and the turbine is connected to a generator which produces electricity. Hence, thermal energy is converted into mechanical energy, and the mechanical energy is converted into electrical energy. Now, let's know the working principle of a thermal power plant. The working of a thermal power plant is based on Rankine cycle, a thermodynamic cycle that converts heat into mechanical work. It mainly uses water or steam as the working fluid and runs through four basic steps. These are pumping, heating, expansion, and condensing. For pumping, the pump is used where water is pressurized. Then water is heated in the boiler to form high pressure steam. The steam expands through the turbine, producing mechanical work. Steam is then cooled in condenser to become water again, completing the cycle. Now, what are the main components of a thermal power plant? The boiler or furnace is where the fuel is burned to produce heat. The heat converts water into high pressure steam. The quality and efficiency of a boiler directly affect the overall plant performance. The steam turbine is rotated by the high pressure steam. As the steam expands, it loses heat and energy, which gets converted into mechanical energy that spins the turbine shaft. The generator is coupled to the turbine shaft. As the turbine spins, it rotates the generator's rotor, producing electricity by electromagnetic induction. After passing through the turbine, the steam enters the condenser where it cools and condenses back into water. The feed water pump then increases the pressure and sends it back to the boiler, making the process a closed loop system. Here you can see the overall operation of a thermal power plant. Fuel is burnt in the boiler to produce steam, which runs the turbine connected to the generator. After that, the steam is condensed and the water is reused. This repeating cycle maintains steady electricity generation. Now let's come to the advantages of a thermal power plant. Firstly, it provides reliable power generation. It can work continuously for long periods. The cost of fuel in case of coal-fired thermal power plant is cheap. It requires less space and can operate in any weather conditions. But there are also some disadvantages. The plants emit harmful gases like carbon dioxide, sulfur dioxide, and nitrogen dioxide, causing air pollution. It have relatively low efficiency, typically 30 to 40%, requires large amount of water for cooling, and the maintenance costs are also high. In this figure, you can see a boiler, a turbine, and a generator connected in series. In general, the efficiency of a power plant is the ratio of output power to the input power. To find the efficiency of a thermal power plant, we first need to find the thermal efficiency, which is the multiplication of the boiler efficiency and the turbine efficiency. That is the ratio of heat equivalent of mechanical energy to that of coal combustion. The overall efficiency is the heat equivalent of electrical output to the heat of the coal combustion. That is the multiplication of the boiler efficiency, turbine efficiency, and the generator efficiency. Now let's solve a mathematical problem from the Power System Analysis book by V.K. Mehta. The following data are given. The maximum demand is 20,000 kilowatt. The boiler efficiency is 85%. The coal consumption is 0.9 kg per kilowatt. The load factor is 40%. The turbine efficiency is 90%. And the cost of 1 ton of fuel is 300 rupees. To get the thermal efficiency, we need to multiply the boiler efficiency to the turbine efficiency. After that, to get the average load, we need to multiply the maximum demand to the load factor. After getting the average load, we need to multiply the average load to the time to get the units generated per annum. After getting the units generated per annum, we can multiply it with the coal consumption in kg per kilowatt to get the total coal consumption. After getting the total coal consumption, we can multiply it with the cost of 1 ton to get the bill. Thanks for watching. Don't forget to like, share, and subscribe to Bolt Mentor for more clear explanations of engineering topic. For any confusion, please let us know in the comment section.